Welcome to the Virtual Tutor Series on Core Mathematics for Senior High Schools. This is part 4 of the lessons on plane geometry. In our last lesson, we covered the introductory part, the various types of angles, and relationships between angles. In this lesson, we focus on angle properties of parallel lines and find missing angles between parallel lines and a transversal. If you are new to this topic, I highly recommend that you watch our previous lessons to acquire the basics before watching this video. Kindly take your book and pen as we zoom into the classroom. By way of recap of our previous lesson, we learned that adjacent angles share a common arm and a common vertex and do not overlap. Vertically opposite angles are two angles that are opposite to each other when two straight lines cross, and these angles are always equal. Complementary angles sum up to 90 degrees, and supplementary angles sum up to 180 degrees. Do well to keep these definitions as they will be useful over the course of this and subsequent lessons. Now, let's proceed to today's lesson. Angle properties of parallel lines. So what are parallel lines? Two lines are said to be parallel if they are same distance apart and will never meet. For instance, if the lines AB and CD are two straight lines maintaining an equal distance apart, known as equidistant, then they will never meet or cross each other. In that case, the straight lines AB and CD are said to be parallel to each other. This can be represented with an arrow on both lines. And we write AB/CD. This is read as line AB is parallel to line CD. Now that we know what parallel lines are, let's quickly take a look at what a transversal is. A transversal is a straight line that cuts across two or more lines. For example, in this diagram, line EF is a transversal as it cuts across the parallel lines AB and CD. When a transversal crosses parallel lines, they form pairs of angles. Corresponding angles are equal. Corresponding angles look like an F shape. On the left side of the transversal, A corresponds to E and C corresponds to G. Therefore, A is equal to E and C is equal to G. And on the right side of the transversal, B corresponds to F and D corresponds to H. Therefore, B is equal to F and D is equal to H. Again, vertically opposite angles are equal. We have already learned in our previous lesson that vertically opposite angles are two angles that are opposite to each other when two straight lines cross. You can think of vertically opposite angles as an X shape. We observe from this diagram that at the crossing point of lines AB and EF, angles A and D are vertically opposite to each other, and angles B and C are also vertically opposite to each other. This implies that A is equal to D and B is equal to C. Furthermore, at the meeting point of lines CD and EF, E and H are vertically opposite to each other, and F and G are vertically opposite to each other. This means that E is equal to H and F is equal to G. Again, alternate angles are equal upon the crossing of a transversal and parallel lines. Alternate angles can be thought of as a Z shape. We can talk of two sets of alternate angles. The first sets are alternate interior angles, and these are formed within the two parallel lines. So C and F are alternating, and D and E are also alternating. Therefore, C is equal to F and D is equal to E. The second set are alternate exterior angles, and these are formed outside the two parallel lines. We observe that A and H are alternate to each other, and B and G are also alternate to each other. This implies that A is equal to H and B is equal to G. Finally, adjacent angles are supplementary. And we already know from our previous lesson that supplementary angles sum up to 180 degrees. Therefore, at the meeting point of lines AB and EF, A plus B is equal to 180 degrees. C plus D is equal to 180 degrees. A plus C is equal to 180 degrees. And B plus D is also equal to 180 degrees. And at the meeting point of lines CD and EF, E plus F is equal to 180 degrees. G plus H is equal to 180 degrees. E plus G is equal to 180 degrees. And F plus H is also equal to 180 degrees. In essence, all the angles with same colors have same size. And any two angles of different colors are supplementary or sum up to 180 degrees. Now, based on these definitions, let's see how we can find missing angles between parallel lines and a transversal. Example 1. In the diagram, LM and PQ are parallel lines. Find the value of x. Solution. The first hint is that when a transversal crosses parallel lines, alternate angles are equal. That is, angle QUV and angle LVU are alternate angles. This implies that angle QUV is equal to angle LVU, which is equal to x. The second hint is that angles on a straight line are supplementary. In other words, the sum of angles on a straight line is 180 degrees. This implies that angle QUV plus angle PUV is equal to 180 degrees. Angle QUV is x and angle PUV is 148 degrees. Therefore, x plus 148 degrees is equal to 180 degrees. Grouping like terms, we have x to be equal to 180 degrees minus 148 degrees. 180 degrees minus 148 degrees is 32 degrees. Therefore, x is equal to 32 degrees. Example 2. In the diagram, MN and OP are parallel lines. Find the value of y. Solution. The first hint is that vertically opposite angles are equal. That is, this angle and this angle are vertically opposite. Therefore, this angle is also 50 degrees. The second hint is that alternate angles are equal. This whole angle and this angle are alternate to each other. This implies that y plus 50 degrees is equal to 105 degrees. Grouping like terms, we have y to be equal to 105 degrees minus 50 degrees. 105 degrees minus 50 degrees is 55 degrees. Hence, y is 55 degrees. Example 3. What is the value of x in the diagram above? Solution. Let's think a little outside the box by extending the parallel lines. Let's also introduce a third line parallel to the first two. And let's assume that this angle is W and this angle is Y. Now, our first hint is that angles on a straight line are supplementary or sum up to 180 degrees. This implies that W plus 130 degrees is equal to 180 degrees. Therefore, W is equal to 180 degrees minus 130 degrees, which is 50 degrees. Again, Y plus 120 degrees is equal to 180 degrees. Therefore, Y is equal to 180 degrees minus 120 degrees, which is 60 degrees. Our second hint is that alternate angles are equal. This angle and this angle are alternating. This implies that this angle is also W, which is 50 degrees. Again, these two angles are also alternating. Hence, this angle is also Y, which is 60 degrees. These three angles are on a straight line, and we know already that angles on a straight line are supplementary or sum up to 180 degrees. This means that x plus 50 degrees plus 60 degrees is equal to 180 degrees. Grouping like terms, we have x to be equal to 180 degrees minus 50 degrees minus 60 degrees, which produces 70 degrees. Hence, the value of x is 70 degrees. Example 4. In the diagram, RS and WV are parallel lines. Find the value of the angle marked A. Solution. The first hint is that corresponding angles are equal. This angle and the angle here are corresponding angles. Therefore, this angle is also 128 degrees. The second hint is that adjacent angles on a straight line are supplementary or sum up to 180 degrees. This implies that A plus 128 degrees is equal to 180 degrees. Grouping like terms, we have A to be equal to 180 degrees minus 128 degrees. (180 degrees minus 128 degrees is 52 degrees. Therefore, A is equal to 52 degrees. Well done. This brings us to the end of today's lesson. In our next lesson, we will cover angle properties of a triangle. If you like this video, kindly give it a thumbs up, share, and leave your comments in the comment section below. You may also consider subscribing to the TVTL's YouTube channel in order to receive notification on educational videos like this. Thank you for watching and see you in our next video lessons.